Hello. In previous lecture, we have seen the calculation of arithmetic mean for three types of data like individual observations or ungrouped data, discrete frequency distribution, and continuous frequency distribution. In this lecture, we are going to study the properties of arithmetic mean. Properties are important for calculation purpose and to understand the arithmetic mean better. So let's have first property, that is sum of observations is equal to the product of arithmetic mean and sum of observations. I have written here symbolically, that is summation xi is equal to nx bar. Let's try to prove this. By definition, what is the formula for arithmetic mean? That is sum of observations divided by total number of observation. If I multiply on both sides by n, then summation of xi will be nothing but nx bar. Why we have given this property? It is to know that to find the value of x bar, it is enough to know the sum of observations, that is summation xi, and total number of observations, that is n. It is not necessary to know the individual observations. So let's have a second property. Algebraic sum of deviations of observations from their arithmetic mean is 0. We have written here symbolically. See, let's try to read this part by part. Algebraic sum, that is algebraic sum of deviation. Deviation means nothing but difference. So here is the subtraction sign. Deviation of observations Observations are xi, that is x1, x2 up to xn, from their arithmetic mean. Arithmetic mean is x bar is 0. Algebraic sum of deviation of observations from their arithmetic mean is 0. So let's understand first what is mean by deviation. So suppose xi is the ith observation and a is any constant, then xi minus a means deviation of xi from a. We have already seen the representation of the statement in equation. So let's try to prove that equation, that is algebraic sum of deviation of observations from their arithmetic mean is 0. So let's try to find how the answer will come 0. So let me take the summation inside the bracket. Summation is varying from I is equal to 1 to n, summation of xi minus summation I varying from 1 to n x bar. So first let's talk about summation x bar. This x bar is constant with respect to summation because x bar is the fixed value and here index I is not given. So so x bar is constant with respect to summation. So we can write summation I is equal to 1 to n x bar as n x bar because summation is varying from 1 to n. So I have multiplied x bar by n. Okay. So what will be next step here? Summation of xi minus n x bar. But this xi is not constant with respect to summation because summation is varying from I is equal to 1 to n and here index is also given as I. So xi is variable with respect to summation. Here x bar is constant with respect to summation. So from the property 1 I can write summation xi is nothing but as nx bar, this nx bar as it is. So nx bar minus nx bar is equal to 0. So summation of xi minus x bar is equal to 0. So algebraic sum of deviation of observations from their arithmetic mean is always 0. So let's have one example in which we will try to prove this statement. Y answer is always 0 of summation of xi minus x bar is not any other number. So suppose observations are 2, 5, 6, 8 and 4. So to prove this statement, these are the xi's, right? x1, x2, x3, x4, x5. To prove this statement, let me first find x bar. So how will I find the arithmetic mean? First, the total number of observations are 25. So the x bar is equal to summation of xi upon total number of observations. So summation of xi is 25, total number of observations are 5. So x bar is nothing but 5. So we got x bar is equal to 5. So next step is we need to find the summation of xi minus x bar. So first we need to find the column of xi minus x bar. This summation is varying from, since the observations are 5, summation is varying from I is equal to 1 to 5. So first observation will be x1 minus x bar. Second observation will be x2 minus x bar. Third observation will be x3 minus x bar. Fourth observation will be x4 minus x bar, and fifth observation will be x5 minus x bar. So we will first try to find this column, then we will find the sum. So we will get the answer of summation of xi minus x bar. So let's find. We have already x bar is equal to 5. So 2 minus 5 is nothing but minus 3, 0, so 1, 3 and minus 1. If you add all these number, you will get the answer 0. So the same way you can take any example, you will always find that summation of xi minus x bar is 0, because x bar is the value. Here our x bar is 5. X bar is the value which lie at the center part of the data. So after subtracting the mean from the values, you will get some value positive, some value positive, some values negative. After adding all these positive and negative values, you will always get answer 0. So our next property is sum of square of the deviations taken from their arithmetic mean is minimum. Sum of squares of deviation taken from arithmetic mean is always minimum. So let's try to prove this inequality using example. I have taken the same data. What I want to prove that, so summation of xi minus x bar bracket square is less than summation of xi minus a bracket square. So to prove this inequality, we need to find first the value of xi minus x bar and xi minus a. So here I have taken a is equal to 4. You can assume a as any number. I have taken a just randomly. So first you will need to find the x bar. As we have calculated earlier, x bar is nothing but 5. So let's find the column of xi minus x bar, that is minus 3, 0, 1, 3 and minus 1. So we need to find the value of summation of xi minus x bar bracket square. So first we need to find the column of xi minus x bar bracket square. Then we will find the sum of this column. We will get the value of summation of xi minus x bar bracket square. So minus 3 square is nothing but 9, 0, 1 square 1, 3, 9, minus 1 square 1. So the answer of summation of xi minus x bar bracket square is nothing but 20. We have taken a as 4. So let's subtract one by one. Our x1 is 2, 2 minus 4 is minus 2, x2 is 5, 5 minus 4 is 1, x3 minus a, that is 6 minus 4 is equal to 2. Similarly, 8 minus 4 and 4 minus 4. Okay, we need to find the summation xi minus a bracket square. So we will find the square and we'll make the addition. So 2 square 4, 1, 2 square 4, 4 square 16, 0. So the answer is 25. Clearly 20 is less than or equal to 25. So here is the inequality, that is summation of xi minus x bar bracket square is less than or equal to summation of xi minus a bracket square. That is, if you can take any value for a, you will always find that this inequality is true. Suppose in other way, we will try to understand that statement. Obviously mean is the center part of the data, so mean will lie somewhere here, and these are the data points. Okay, same data points are lying here, and we are assuming a somewhere here. So suppose somewhere here, you can assume a at any part of the data. I have assumed it at here. You can take it at here, anywhere. Since it is not a mean, so this cannot be lie at the center part of data. So I have put it in either side. You can plot it here, here, anywhere. Okay. So if you find the difference of that, since these are the points, that is x1, x2, these are the x3, something like that, then x1 minus x bar, x2 minus x bar, x3 minus x bar, similarly this type of these subtraction. So the since the mean is lying at the center part of the data, the difference will be minimum as compared to this difference. Okay, so eventually summation is minimum, and in other case, suppose this constant is here anywhere, then the difference is maximum on the either side. Here is the difference is minimum, but in the other side the difference is maximum. Ultimately, so the answer of summation will be maximum. So this inequality is always true. So our next property is minimum of x1, x2 up to xn is less than or equal to x bar is less than or equal to maximum of x1, x2, xn. It means arithmetic mean is always lies between minimum of the observation and maximum of the observation. Let's have same example. We have taken the observations like 2, 5, 6, 8, 4. Our arithmetic mean is equal to 5, and what is the minimum value? That is 2, and maximum value is 8. So arithmetic mean is always lies between minimum of the observation and maximum of the observation. Why we have given this property? Because this gives bound of arithmetic mean. If x bar does not lie within a minimum and maximum of the observation, then it is indication of error in computation. So our next property is property of combined mean. Let x1 bar be the arithmetic mean of the first group of size n1 and x2 bar be the arithmetic mean of the second group of size n2. Then combined mean xc bar is equal to n1 x1 bar plus n2 x2 bar divided by n1 plus n2. Why we have given this property? Many times it is required to compute mean of two groups combined together if means and sizes of groups are known. How this formula is, how the formula is formulated? Xc bar, that is combined mean, is equal to, as we have given that x1 bar is be the arithmetic mean of first group of size n1. So total sum of observation from the first group is nothing but n1 x1 bar according to the property of 1 plus total number of observation from size from group 2 is nothing but n2 x2 bar divided by total number of observations, that is n1 plus n2. Our next property is effect of change of origin and scale. I have made the separate video to explain it in detail for this property. So I have given the link in the description box for this video. Till now, if you have any doubt related to the properties of arithmetic mean or calculations of arithmetic mean, kindly comment me in the comment section. Thank you and all the very best.